Okay, this is part two of our video about time series decomposition. So if you're watching this video and you don't know what's going on, go back and watch the first video, part one. Okay, so I had to stop because I reached the maximum time to record the video. So I'm gonna keep moving on from here. Okay, so I stopped here at step 4 with the quarters, the year, and computing the trend. So you know that this is the trend that moves along the time. Now I have to come up with the forecast. The forecast, remember from our slides, the forecast is the demand, in this case the trend that we just did. Remember we got the coefficient. This A is this number right here, and this B is the coefficient that connects the time, in this case measured in quarters, with the demand. Okay, so this is the demand, the trend in the demand. So this is what we did. Now we have to multiply by the season factor, okay, to get finally, that's finally the forecast. We get this trend and multiply by the season factor related to spring. So we go up and multiply by spring. And then we get the demand, the trend in the demand for summer, and multiply by the season factor for summer. And we do the same thing for the other two. And now this is the forecast. This is the final forecast with trend and seasons take into account. Okay, so what we did here is this entire formula here, but you see how many steps we had to take in order to be able to get that. Okay, all right, so that's it. This is how you move on with seasonality in a multiplicative seasonality model. Okay, this is what we did, all the steps. And if you're doing an additive seasonality model, you do the same thing, but instead of multiplying by the seasonal factors, you add the seasonal factors. So imagine you have to go through all these steps: step 1, step 2, step 3, step 4. That is, you have to decompose the seasonal factors like we did here, and then you have to seasonalize demand like we did here, and then you have to compute the coefficients, what we did here, these steps, by including a time variable here. In this case it's quarters, could be months, could be days, could be hours, could be whatever you want. And then in the step 4 you compute the trend by using these coefficients like we did, and this trend is this part of the formula. But the final forecast using the additive model is that we sum a given amount to this demand. So instead of multiplying, we add a given amount to this trend, depending on how the season hours. So here, instead of a season factor 0.69, we would have season factor like 100 units more for spring, 200 units more for summer, less 100 units for fall, and less 200 units for winter. We would have amounts that we would add to get the final forecast. That's the difference between the additive and the multiplicative seasonality models. Okay, and going back to this example, you can go and look at the class notes and see that this is what we have for seasons in the year 4 in the table in page 18, and you can go ahead and compute for all other seasons if you want, and check to see if you are doing everything correctly. Okay, that's it.